Hello guys, this is Daniel and today we are going to continue with the testing of our smart contract guess the number. So as you remember, we have this smart contract here, which is a guess the number smart contract, where we have at the moment of deployment we set up a secret number in the contract and we deposit 10 ETH. Those 10 ETH become a price, and then whoever gets the number correctly, the secret number that we set, obtains the 10 ETH plus any fees that have accumulated for any person that have played with the contract, because playing, giving a try at guessing the right number, has a fee of 1 ETH. So in the previous video, as you remember, we created a function to test the contract in the event that someone play guessing the wrong number, and we saw that everything was working properly. Right now we are going to test the other behavior, which is when someone plays with the contract but guesses the right number. So let's do it. So let's do our continue our testing right now. What we're going to do in this case is first verify that we are in the right folder. So we're guess number folder, which is our main Brownie project around here. We test that we are properly connected to our local ganache because we need to deploy this contract. So we're going to do Brownie console. And of course, we are assuming that you are inside your virtual environment, right? That's a prerequisite in everything Python related. So we have everything there. Let's exit. And we verify that we are connected, so let's get it going. What we're going to do for this function is very similar to what we did before. We need to collect what is the balance of the contract and the balance of the player before the play function of the smart contract is called. Then we call the play function of the smart contract with the right number, and then we do our assertions. So let's set our our variables to collect the values of the contract before the player plays. So we're going to do PreContract Balance, and that's going to be equal to guess number, which is the contract that we are deploying, and we call the function get balance inside that contract. It's very similar to what we did in the previous function here. Other thing that we need to remember is that in these functions we are passing this fixture, and if you don't know what a fixture is, you can watch the last video that we did, the previous video, where we explained that a fixture, it's a decorator that we put on top of a function that makes us able to return whatever value this function is returning and pass it as an argument to another function here, and that is allowing us to don't have to deploy the contract every time that we call it, because the deployment is part of the fixture. So that's it. So we get this one guess number, we're getting it here, we're getting this from this argument, and that argument comes from this fixture over here. And then we are going to get another variable that is the player balance, and for that we need to get what is the current balance of the player before he plays. So that depends on what account we're going to use to play. We're going to use account 1 again, as we did in the previous function, and we're going to do balance, and that's it. We have our values properly collected. Now we need to call the play function, and for that we need to submit two parameters, right? One is the guessed number and one is the address of the player that is playing. So let's do that. So we have to do a guess number that play, and we are going to guess the number correctly. So the guess number that lives in this deployment is 7, so we're going to set 7, and the address of the player that is playing is whoever we are getting the balance here, right? So it's accounts 1, and this is coming from our local ganache environment. We are going to address here, and that's it. Now we need to also submit, and this is something that we need for calling a function that it's payable, is that we need to submit who is triggering the function, right? So we need a from in this dictionary, which defines the parameters of the transaction itself. So we need a from, and that is going to be accounts, and the accounts that we are paying right now. And when we set it like this, we basically are leveraging Brownie functionality in the sense that the transaction is going to be signed automatically. So we don't have to care about private keys because we're in our testing environment. And the value that we want to submit, as you remember, that's the other parameter that we need for the transaction, is going to be 1 Ether. So we have here the transaction create for calling the play function in the contract. Now time for assertions. So for the order of the assertions here, we're going to change it a little bit from what we did in the previous example because I know exactly what assertion is going to fail actually. So let's do assert, and for this one we are going to do a guess number, and let's do the accounts first. So we're going to do account 1, which is the account that we are playing with, and balance should be equal to the pre-player balance that we just created plus, you guessed correctly, PreContract Balance. Because when the player gets the number correctly, the amount of ETH inside the contract, which we collected here in contract balance, in PreContract Balance, is going to be transferred to the player ETH account. So those two will add up, and that should be the balance that we get after guessing the number correctly. So that's it. The other assertion that we're going to have is that the current state variable, that it's coming from these states over here. It's part of the contract, and it defines whether the contract is open. That means that the contract can be played, and the contract is already completed. That means that the contract will not allow us to play. So that variable should be equal to 1 because the state of the contract should change after guessing the number correctly. And then the last assertion is going to be that the guess number get balance, which is the balance of the contract, should be equal to 0. And we're using that because what happens is that if the pre-contract balance, which the balance of the contract before playing, was transferred to the player, then the balance of the contract should be 0 afterwards. So we erase this return statement here, and apparently we have everything ready here. So we have two tests. One is the test to play the wrong guess, and the other one is to play the right guess. One quick note, this is something that I didn't touch in the previous video, but all your functions for testing should start with a keyword test, then underscore and whatever you want to call it. But this is a convention that you have to follow because that's the way that the PyTest library is going to recognize that these functions are tests. So let's do it right now. We're going to do Brownie test, and let's see what happened. And we have one test failed and one test passed. So let's go to examine what happened here. And we had these two dots here means the test. So we have one test to test. The green dot means that the test passed, so that's this one. And the F here means that one test failed, which is this one. And then we can check what was the status of the test. So it will give us the assertions. And we have the assertion that the account balance is equal to the balance that the player had before playing plus the balance that the contract had before the player played. And this is correct, so that means that the balance is properly transferred. Then we know that the core state changed to 1. That means that the contract was completed. So that's great. And then we get the balance value is not equal to 0 in the contract. So let's check it out, and it's telling us that the assertion error is that 11th is not equal to 0. So for that, we will have to go back to the contract, and we're going to verify what went wrong, and that's in the function play. So let's go over to this if statement. If guest number equals secret number, the guest number is sent as a parameter here, then the player gets the balance of the contract. That's address that this balance is transferred to the player, and the core state is equal to complete. And as expected, what we don't have here is that we don't have a way to again reset this variable balance to 0. So let's do it right now. So we're going to do balance equal 0. As easy as that. We put the semicolon, we save it, and that is our contract right now. Now to actually test it again and make sure that it's passing, we need to erase everything that is here. We don't have anything in interfaces. Let's erase the test JSON here, and we are going to also erase this guest number JSON because that's the previous deployment, that's the previous compiling, and then we are going to do another Brownie compile. This is going to take a while, but what we're going to do with this statement is to compile the contract again. Now the contract has been compiled, so let's do clear, and then let's return to our function for testing here. We don't really need to do that, but let's run our test again. So let's do Brownie test. And we have the 2 tests passed. So as you see, guys, testing with Brownie is very easy, and the function of testing is to let us know that the smart contract has the behavior that we intended it to have. This will allow us to do all this bug catching in our test network before we do anything wrong in the production environment in the mainnet. And this is something very important. This is key. Today we learn how to do a test and how to fix our smart contract when something is failing using our fail assertions. See you in another series and in another video next week.